Alright, this video is going to look at solving a systems of equation using the elimination method. I'm going to start with some easy examples where it's already set up to eliminate, and then I'm going to get to some more challenging examples as it goes on. Each time you get to an example, I'm going to ask you to pause the video, try to work it out on your own first, and then come back and watch it. That's the purpose of this video, so make sure you have a pencil, paper, and calculator ready to go. Pause the video, try to do the first one. Alright, if you're coming back in, the elimination method, the most important thing to line up is our equal signs. As we've got our equal signs, they're kind of lined up here. I mean, it's pretty close, close enough that we can clearly see both sides of our equation. And we want to identify which variable we want to eliminate. In this case, I can see right away that it's already set up to eliminate my x's. How do I know? My x's are the exact opposite term. 4x and negative 4x are exact opposites, and they'll eliminate. So in this case, it's already set up to combine my two equations together and eliminate my x, because when I combine those cancel to that. Negative 2y plus 8y gives me 6y equals negative 12 minus 24 is negative 36. And then from there I can divide by 6 on both sides to find that y equals negative 6. All right, and at that point I know y, and to find x I go back to either of my original equations. It really doesn't matter. I'm just going to take my first one, and I'm going to replace y with what I found. And I'm going to solve for x. Now, in the elimination method, it's quick to get to one variable, but it's a little bit longer to get to the second one because I have to do all the math involved with that. Negative 2 times negative 6 is going to be giving positive 12. Subtract 12 from each side. Negative 4x equals negative 24. Divide by negative 4. I find that x equals positive 6. Look at that. Hey, 6 and negative 6. And therefore, I want to check my answer, make sure that works. Now, if I use this equation to find my my second variable, I must use the other equation to check it. So I've got to check it with 4 times 6 plus 8 times negative 6 equals negative 24. All right, 4 times 6, well, that's 24. 8 times negative 6 is negative 48. And negative 48 and positive 24, that gives me a negative 24. So therefore, it did work out. My answer is correct. I'm going to write it as an ordered pair, 6, comma, negative 6 with parentheses because it is an ordered pair, and make it stand out above the rest. All right, that's my first one. Let's take a look at the next one. Pause the video, try to do it. All right, coming back into it, this time my y was set up to eliminate. If you notice, it was already negative y and positive y. They're the exact opposite of each other. So I can just line up my equal signs and add my two equations. These are going to cancel each other out, but x plus 2x is 3x. And over here, 11 plus 19 is 30. Divide by 3, and I get x right off the bat. Again, getting that first variable can be rather simple. However, I got to go back and get the second variable. I'm going to choose the first equation here. So 10 for x minus y equals 11. And I got to solve that. I'm going to subtract 10 from each side. I find that negative y is equal to 1. Therefore, y must equal negative 1, the opposite, right? If you don't know that or see that, you can divide both sides by negative 1 to get there. All right, but let's check my answer now. So 2 times 10. Notice I'm using the second equation to check it. All right, 2 times 10 plus negative 1 equals 19, and 2 times 10 is 20, minus 1, and that indeed does equal 19, and therefore my answer is correct, and I can write it as, that's not it, I can write it as an ordered pair. 10, comma, negative 1, always x, comma, y, and make your final answer stand out more than the two answers prior, because x and y are just part of the answer. Together, they're an ordered pair. That's our final answer. All right, let's try another one. All right, this one's a little bit different. Nothing's set up to eliminate right away, but you're going to have to do something to get them set up to eliminate. Try to do that now. All right, I'm taking it you already tried to solve it. Let's come back into it together. I notice that I have none of these are the exact opposite, and I need to decide which variable I want to eliminate. Now, you could eliminate either one, but in this case, the easiest one is going to be eliminating y. I see that they're both negative 9y. That means I can simply multiply one of my equations by a negative 1 to make it the exact opposite. All right, that means that 2x is going to become a positive 2x. Negative 9y is going to become a positive 9y, and negative 25 is going to become a positive 25. All right, the bottom one I don't have to touch, because if I don't touch it, I have negative 9y. Notice those are exact opposites of each other, which is exactly what I wanted. Now I can line up my equal signs, add the two together, and I find that 2x and negative 4x gives me a negative 2x altogether. 9y and negative 9y cancel or eliminate, and 25 minus 23 is 2. Then I can divide by negative 2 to find out my value of x. In this case, negative 1. Once I got that, I want to go back to either of the original equations to find my other variable. Again, it doesn't matter, but go back to the original. I'm going to take the first equation. I typically use the first equation just so I'm consistent. And you're going to solve for y. And once I got y, let's check it in the other equation to make sure it works. Look at that, it worked out. So therefore I know this is a solution to both equations, and I'm going to write it as an ordered pair, negative 1, comma 3 with parentheses, and make it stand out more than the other sub-solutions. All right, good, let's take a look at another one. Now we're seeing a system of equations where you can't just simply eliminate right away, and it's not as simple as multiplying by negative 1. You're going to have to find something else to multiply here. All right, so go ahead, pause the video, good luck. All right, if you're coming back into it, you had to decide which variable you wanted to eliminate for the first step, and you can eliminate either one. It does not matter. I'll show you both. I'm going to start with x. If I wanted to eliminate x in this case, I notice that I have 10x, and I need to get 5x to be the opposite of that. Well, what times 5 gets me to the opposite of 10? Well, the opposite of 10 is negative 10. Well, I need to multiply the entire top here by negative 2. That will take negative 2 times 5x and give me a negative 10x. That's what I was looking for. Plus, negative 2 times negative negative 2 times y is actually going to give me a minus 2y. And 9 times negative 2 is going to give me a negative 18. All right, at which case the bottom I didn't have to change because 10x, notice they're exact opposites. Negative 7y equals negative 18. And now I can line up my equal signs. I can eliminate my x's because they're exact opposites, giving me negative 9y equals to negative 36. Divide by negative 9, y equals 4. Now with that done, I can plug it back into either of the originals. Again, it does not matter. I take the top one just to be consistent, and I know that 5x plus 4 equals 9. Subtract 4. So y equals 1 in this case, and I'm going to check it with the other equation, make sure that it is correct. So 10 times 1, I'm sorry, that's an x going through there. 10 times 1 minus 7 times 4 equals negative 18. Well, that's 10 minus 28, and negative 18 does indeed equal negative 18. It worked. So my answer would be 1, 4. And I'd mark that out and put parentheses. Now, I'm going to show you the same exact problem. This time, I'll eliminate y, because you could go either way with this one. Eliminating y is just as simple. I look at my y's, and I see negative 7y. What's the opposite of negative 7? Well, positive 7. Can I multiply anything by y to make it a positive 7? Yes. I could multiply this entire first equation by 7. If I do that, 7 times 5 is 35x. 7 times y is 7y. And 7 times 9 is 63. Well, now the bottom I don't have to change because it's 10x and negative 7y, which is great, equals negative 18. And I can just line up my equal signs here. All right, and I can go ahead and put them together, give me 45x. All right, because 35x plus 10x gives me 45x. My y's are going to eliminate here. And then I can do 63 minus 18, and 63 minus 18 is 45. And I divide by 45 on both sides. seeing that x is 1. Hey, that's the exact same thing we found out going the other way. But now let's plug this in. Again, you could do it either way. So 5 times 1 plus y equals 9. So that's going to give me 5. Subtract it. Find that y is equal to 4. And then I check it as we did before. 10 times 1 minus 7 times 4 equals negative 18. So that's 10 minus 28. And it works. Look at that. Voila. All right, so it does not matter which variable you choose to eliminate. It's a matter of choice, and you go with the one that's the easiest. Here, it's just as easy to do either one. I personally would have eliminated x because multiplying by 2 keeps things smaller, but it does not matter. Let's try another one. All right, take a look at this one. Pause the video and see if you can get it. All right, if you're coming back in now, the variable to eliminate here is definitely x, because if I look at 7 and 5 in my y's here, if I look here and here, I can't multiply 5 by anything to get the opposite of 7, negative 7. I can't multiply 7 by anything to get the opposite of 5, negative 5. So it's much easier to look at negative 3x and negative 9x. Well, I'm going to go with the smaller one here. What can I multiply negative 3 by to get the opposite of negative 9? Well, that means positive 9. That means I can multiply by negative 3. If I do that, negative 3 times negative 3x gives me 9x. That's what I wanted, the opposite of negative 9x. But I have to multiply that to everything. All right, sorry, it's not going to be a plus. I keep doing that. So if we got 7 times negative 3, that's going to give me a negative 21y. And if I do 3 times 16, I'm going to get a positive 48, because it is a negative 16 and a negative 3. Gives me a positive 48. All right, so that's my top equation. My bottom one I don't have to change. Negative 9x plus 5y equals 16. And now I can line up my equal signs. My x's will eliminate each other. And I'll get negative 16y equals 64, and divide by negative 16. Those cancel, and y in this case equals negative 4. Now I can take that, I'm going to use my first equation, negative 3x plus 7 times negative 4 equals negative 16, and I'm going to solve. Negative 3x minus 28. And I find that x equals negative 4. Look at that. Hey, they both are the same. Let's make sure we're right. Let's check it. Look at that. It worked out. Sorry. Wait, hold up. I apologize. Those are all positive. All right, so it worked out. That's great. Therefore, we know that it is our correct answer. And I'm just going to put negative 4, comma, negative 4, and box it out. All right, let's take a look at another one that's a little bit more challenging. All right, take a look at this next example. This one is a little bit more challenging because this one requires you to multiply both equations by 2 different numbers in order to eliminate a variable. Again, you could choose either variable to eliminate. That is completely up to you. But go ahead and try it on your own. Pause it. All right, coming back in. Which one you decided to do, it doesn't matter. I'm going to tell you which one I'm going for just because it makes it a little bit easier here. I choose the ones that have the smaller numbers. So I'm going to eliminate x. Now, I noticed that right away, I can't multiply 4 by anything to get 7. And I can't multiply 7 by anything to get 4. Some people try to go by decimals, which you can do. That's perfectly okay if you don't mind going the decimal route. But otherwise, it's a little bit of a challenge. 8 and 9 just get a little bit bigger, okay, because 8 and 9 are bigger numbers than 7 and 4. So what I need to do is find a common multiple between 7 and 4, and I'm going to have to make them the opposite. Well, the first number that both 7 and 4 go into is 28. All right, in fact, 7 times 4 is 28. If you have trouble finding that common multiple, let me know. All right, but I just basically do this. 4, well, that's 4, 8, 12, 16, 20, 24, 28. 7 has multiples of 7, 14, 21, 28. Notice that's the first one that they both have in common. So that's why I'm choosing 28. Well, what times 7 gets me to 28? Well, I'm going to multiply it by negative 4 because I want to make it positive 28. Negative 4 times 7 is positive 28x. Negative 4 times 8 is going to give me a positive 32y. And negative 4 times 9 is going to give me a negative 36. All right? Now, on the bottom one, I need to ask what times negative 4 gets me to negative 28. Again, I want this to be the opposite so that these two right here cancel each other out. So I need to multiply this one by a positive 7. That means that 7 times 9 is going to give me a positive 63y, and 7 times 22, or negative 22, is going to give me a negative 154. Now I can line these up here. All right, my x's will eliminate each other, and if I add these two here, I get 95y, and then negative 36 plus 154 gives me a negative 190. And if I divide both sides by 95, I find that y equals negative 2. All right, so that's if we went for y first. Now from there, I need to do what I've always done with the others, and I'm going to erase these here. All right, I'm going to always do what I did and take this first equation. I'm going to plug in what I know. All right, and I'm going to solve for x. So negative 7x plus negative 8 and negative 2 is 16. And there we go, subtract 16. All right, we find that x is equal to 1, and then we test it. All right, we come to this middle one here, and I'm just going to come down a little bit lower there, all right, to give myself more room. All right, and if I plug that into my calculator, I find that it works. All right, negative 22 equals negative 22. That proves that my answer is correct, and therefore I can write my answer as an ordered pair. Always x first, then y, and box it out. Make it stand out better than anything else. All right, let's take a look at another one. Again, this one's going to require you to multiply both equations by two different numbers. Just to give you a heads up, I would probably go for y in this case. All right, the reason I would go for y is because 2 and 7 are smaller than 4 and 10, and they're already positive and negative, so they're already opposite. So that does make it a little bit easier. But you could do either. Go ahead and pause it, see if you could solve for y. All right, coming back in, if you pause the video now, let's take a look. I'm going to try to get y to eliminate. So I want my y's to be the exact opposite. And in order to figure out what the least common multiple is between 7 and 2, I'm actually going to list the multiples of the larger number. And every time I list one, I'll just check, does the other number go into it? So 7. Does 2 go into 7? No, it doesn't. 14. Does 2 go into 14? Yes, it does. 14's my goal. So I want to try and make this 14 and this 14. That's my goal here. So I need to ask myself, what am I multiplying by to get there? Well, what times 2 is 14? Well, 7. All right, and what times 7 is 14? Well, 2. All right, so let's go ahead and do that. Let's multiply both of these out. 7 times negative 4 is negative 28x, and 7 times negative 2 is negative 14y, and 7 times 14 is going to give me 98. Now multiply by 2, so I get negative 20x. I get positive 14y. That's what I was looking for, those two right there. Make sure they cancel each other out. And negative 50. Line up my equal signs. Those will eliminate as planned. And I get negative 48x equals 48. And I can divide by negative 48 on each side. And I find that x equals negative 1. All right, plug it into the first equation here to figure out what my other variable is. So y is -5, and then I'm going to check to make sure that it works in the other equation. It works, look at that, and therefore I write my answer x, comma, y with parentheses and make it stand out. All right, let's check one more here, one more time. Here we go. All right, take a look at this equation right here. Again, this system of equations, I can't multiply just one equation. I have to multiply both here by two different numbers. You can pick either variable, but to make things easy, I would go for x this time. Two reasons I'm going for x. One, they're already positive and negative. Well, the y's are positive, negative too, but 2 and 5 are smaller than 8 and 20. So it's just going to be smaller numbers to work with. Pause it, try to do it on your own. All right, coming back into it, if we're multiplying these equations, we want the exact opposite. I need to find the common multiple between 2 and 5 to figure out which number we're shooting for here. I'm going to take the larger number of 5 and start listing its multiples and see when does 2 go into them. Well, 2 doesn't go into 5, so it's not that one. Next multiple of 5 is 10. Oh, 2 goes into 10. So my goal is to get a 10x up top and a negative 10x on the bottom. That's my goal. So what do I need to multiply by to get there? Well, 2 times 5 is going to get me to 10. So I'll multiply everything there by 5. So that's going to give me 10x plus 5 times 8 is 40y equals 5 times 6 is 30. On the bottom, what multiplies by negative 5 to get to negative 10? Well, that's going to be 2. All right, so then negative 20 times 2 gives me negative 40y. And I'm going to get negative 15 times 2 gives me negative 30. All right, now these are all set. I can line up my equal signs, and I can add together my variables. Now, these ones here are the exact opposite. That's what I was going for, so they're going to eliminate. Now, 40y plus negative 40y is going to give me 0y's. You might think that's a problem because these ones also eliminated here. All right, but I still end up with 0. So basically on this left side, I don't need to write 0y. I can just write 0. They all eliminated. On the other side, 30 minus 30, well, that's also going to be 0. So we ended up with something very, very unique here. What happened is everything canceled out. Well, what do you do when the variables drop out of an equation? You always ask yourself one question. Is this true? All right, and that's what we want to ask ourselves here. The variables dropped out, so what's left? Is that true? Does 0 equal 0? Well, yes, 0 equals 0. It will always be true. And since it will always be true, therefore x equals all real numbers. X can be any value that we want it to be. All right, y can't be just any value. Y is dependent upon x, obviously. So we could get all the different values of y, but it will depend on x. That's why we say x is all real numbers, because x is our independent variable. All right, so we have all real numbers. This tells us that our two lines, all right, in this case, our two lines are the same line. That's why they have infinite solutions. They will cross at every single point on their line, because every point that's a solution to one line will be a solution to the other line. All right, great work today.